Hello everyone, I am Videsh Goel from Thapar University, Patiala, and today I am going to discuss with you the Android memory management. This project is under Samsung R&D Institute in Noida under the supervision of Mr. Pritam Roy Biswas, the lead engineer in SRI Noida. Android is an operating system for embedded devices which have limited processing power and limited resources such as available memory, battery life, and other hardware resources. Memory management has always remained a problem for these devices as the optimal concepts used for memory management in Linux cannot be applied here due to limited resources. It remains a big problem for these devices to choose between performance and the battery life. Android is an open source and its all code is available on the internet under Google's open source project. So anyone can modify this code and build his own version of Android with great optimality or increased optimality. Many apps and services are being made for these devices to make this memory efficient, but still the performance is not up to the mark. Despite of using more RAM and more powerful processors every year in new models, the device's memory efficiency is not up to the mark. There are still problems like lagging in large apps and the launch time of apps is not that much improved. Multitasking is still a problem when using some apps together. So this project is about finding out causes of this problem and if possible suggest some solution to these problems. This is the architecture of Android and the memory management module inside it. First of all, there is a foreground process on which the user is doing something. Then there is a visible process which is responsible for hosting the foreground process. System services are responsible for providing system resources to the applications running in the background and to the foreground application. Background services are started by the user to do some task in the background for the current application or for the other background application. Cache processes are the processes running in the background. Now talking about the Android framework level. Activity Manager is solely responsible for managing the Android framework. Together with its support services, it is called the Activity Manager services. It transacts with the process Zygote to launch applications, and it transacts with the Android low memory killer to provide OM adjacent values to the low memory killer. It is responsible for passing intents in the system. It is responsible for launching of the activities. It is responsible for interacting of the Android components and the Android applications between each other. Now talking about the low memory killer. Low memory killer is invoked when the system memory is low below some thresholds provided by the Android. It is provided by the Google on the top of the Linux out of memory killer to provide some modification to the Android binary to handle the low memory scenarios well. Now Linux don't have a low memory killer in its kernel. So out of memory killer is invoked to kill some processes out of the memory. Low memory killer gets the OM adjacent values from the activity manager, which analyzes the running time of every application of the system to calculate its OM adjacent. OM adjacent is calculated on the priority of the processes depending on whether it is a foreground application, a background application, a system services, a background service, or any other type of process. Activity Manager is also responsible for caching of processes in the background so that multitasking can be done. Out of memory killer is invoked in the Android when low memory killer is not able to kill some processes and gain some memory. So Android calls Linux kernels out of memory killer to kill some processes out of the memory so that the new application can be launched. Now talking about some kernel optimization. First of all, there is ZRAM. In Android, there is no swap space. So there is a suggestion that the compressed space can be used for swapping the processes out of the memory and temporarily work as the swap space. Processes would still be stored in the memory in the RAM, but they would be compressed to store to store in the RAM, and so that more RAM would be available for the foreground processes, and there will be less lagging in running the heavy apps. And there is a phenomena of kernel same space merging used in the Linux to merge the similar pages in the RAM used by the different processes. Copy on write phenomena is used in this process, so that one process is to modify the shared page among several processes. The page is copied to the free memory area, and then modifications are done on it. Compaction is the technique of merging the holes in the memory to produce a large free space in the memory. Now these are very good kernel optimizations which can be applied to Android. But what can be the problems in these optimizations applied to the Android? These tasks consume so much processing power. Therefore, if these algorithms are used in Android, the battery power of the Android devices would be consumed too fast. So we are again in the dilemma to choose between the performance of the device or the battery power of the device. Now hence the Android memory management architecture can be broken down into the framework level and the kernel level. At the framework level, we can use activity managers service. At the kernel level, there are low memory killer and the out of memory killer, so that we can provide optimization for the framework level or the kernel level to make the Android more memory efficient. Now we are going to analyze these three components in Android, so that we can provide some suggestions of optimizations in the Android memory management module. In the analysis of out of memory killer, we took some scenarios like where one process is bigger than the other processes, or where one process is running for more time than the other processes, and some other scenarios, and we analyzed that out of memory killer doesn't kill processes on the basis of history. Thus, if one process was killed in the same scenario in the past, the same process will be killed again. Out of memory killer would not remember that it killed the same process again. So we can provide some optimizations on out of memory killer, so that one process is not always thrashed. Here is an analysis of the processes killed in the out of memory killer. We can see that process 9 is always the one which gets killed. So if process 9 is our important process, then load on the memory is increased by the out of memory killer. We can provide some solution by taking the logs from the activity manager service and providing it to the Android out of memory killer, so that one process is not always thrashed, and if that process is coming again and again in the memory, it remembers that it has not to kill that process again in the future. Now talking about the analysis of the low memory killer. Some min-free thresholds are set in the low memory killer, so that when the system memory drops down below these min-free thresholds, the low memory killer is invoked and it starts to kill processes. In our analysis, we found out that these min-free thresholds can be modified according to the device resolution, so memory management module can be made more efficient. Now talking about the optimizations at the framework level. Activity Manager service is responsible for caching the empty apps in the background. Empty apps are the processes that has no active component running in the system, but they are still in the memory, so that the launch time of the applications can be reduced. So we can add some modification to the Activity Manager services, so that it caches the processes efficiently and the launch time of the applications can be improved. So this was the summary of the Android memory management project carried out to improve the efficiency of the memory management module in the Android devices, and still it is a vast topic and research is being done in this area to improve the memory management module of Android further. Thank you.